question 23 is another interesting question. So we want to know how many ordered pairs m comma n of positive integers with m greater than or equal to n have the property that their squares differ by 96. So this is a pretty short problem. So they say like the difference of the squares differ by 96. So m is greater than n. So essentially the question is saying m squared minus n squared has to equal 96, right? The difference in the squares is equal to 96. So we want to find how many solutions there are to this equation. So we see this left side. Whenever you're given like questions about positive integers and equations, and you see this difference of squares, it's almost always a good idea. Just might as well factor it, because factoring gives us lots of really nice like tricks that we can use, especially with these equations involving positive integers. So we can factor the left side is m minus n times m plus n, and on the right side you get 96. So basically, essentially what this is saying is the product of two numbers. So in this case, we have m minus n times m plus n equals 96. So if I said, for example, m minus n is a, m plus n is b, right? Then that's essentially saying a times b is 96, m minus n is a, m plus n is b, right? I'm just defining these new variables a and b. So if I were to solve this equation, these two last equations here, you can just add the equations. You get 2m equals a plus b. So you get m is equal to a plus b over 2. And similarly, you can easily find that n is equal to b minus a over 2. And the important thing to notice here is remember that like you might just be tempted in this question, right? You might say, oh, to answer the question, we can just look at this equation. A times b is 96. We can find how many values, how many pairs a comma b there are, right? We can say, oh, a is 1, b is 96 works. A is 2, b is 48 works, right? And test out all the possible values of a and b. But it turns out we can't exactly do that. Because, for example, if we were to look at this over here, a equals 1, b equals 96, then m, by this formula, m would be a plus b over 2. So then m would be 97 over 2. But that's not an integer, which is bad, because the original question said that m and n had to be positive integers. So essentially, we can't have a is 1, b is 96. And if we take a closer look at these equations, that's essentially saying that a plus b and b minus a, they both have to be divisible by 2 in order for m and n to both be positive integers. But in order for a plus b to be even, that tells us that a and b have to have the same parity. And what that means, parity is just like a fancy way of saying whether or not a number is even or odd. So in order for a plus b to be even, we have to have a and b both be even, or they both be odd. So, which is why a equals 1, b equals 96 does not work. Because in that case, a is odd, but b was even. They had different parities, which is why m and n were not positive integers. But on the other hand, a equals 2, b equals 48, that like indeed works, because a and b are both even, so they have the same parity. So that tells us like if you use these formulas, m is 25, n would be 24. Actually, not 24, 23. So this would turn out to work. 25 squared minus 23 squared. If you wanted to verify that, you would get 96. So now we can kind of list out the possible values, right? So a comma b, you have 1 comma 96, 2 comma 48, 3 comma 32. You'd have like 4 comma 24. 5 does not work because 5 is not a factor of 96. 6 comma 16, 8 comma 12. And from here, we can actually stop. We don't have to continue. And the reason is because the next ordered pair that works is going to be 12 comma 8. But we don't have to worry about the cases when b is less than a. Because if b is less than a, then looking at this equation here, if b is less than a, then n is going to be negative. And that violates the condition that n has to be a positive integer. So like, since n has to be a positive integer, B has to be greater than A. So that means we can kind of like ignore all the ordered pairs where the B value is greater than the A value. So we can just essentially like annihilate that one and just consider these 6 possibilities and evaluate them one by one. So again, we just saw that like 1, 96 is invalid because 1 and 96 have different parities, right? 1 is odd, 96 is even. But 2, 48 works, right? Because they're both even numbers. And they have the same parity, so that works. 3, 32, that does not work because 3 is odd, 32 is even. They have different parity, so it does not work. 4, 24 works because they're both even. 6, 16 works because they're both even. 8, 12 works because they're both even. So in this case, we have a total of 4 ordered pairs of positive integers m, n, so that their difference of squares is equal to 96. And going back to the answer choices, we find that the answer is B, 4, and yeah, that's how you do the question.